Hello, everybody. Welcome to WebAssembly Unleashed, your source for news and views about the world of WebAssembly, 2 years on the air proudly. I'm your host, Joel Moses, and joining me are my regular co-hosts, Oscar Spencer, and our good friend and regular Matt Yacobucci. And joining us again today is our friend and coworker, Pat Hickey. Now, today is part 2 of the special episode that we began last time. We're reviewing the state of things in WebAssembly as they work themselves through the process for open standards. You know, open standards where acronyms go to breed like rabbits.
Indeed.
We're going to talk amongst ourselves about things we've noticed, things we're watching, things we're not so happy about in the world of WebAssembly. I think we called it Thunderdome. And we're back in Thunderdome today to keep it going. So, Oscar, where are we? I think we're in phase 3.
Yes, we were in the middle of our phase 3 proposals. I believe we already talked about type reflection, and that brings us to the next proposal, which is ESM integration, another one of those fancy acronyms. So ECMAScript modules. Folks, for me, this is a big deal. I know that we're all WebAssembly outside the browser, folks, but this was my dream for WebAssembly, 10 years ago, which is crazy to think that WebAssembly is 10 years old now. But this was really my dream of, hey, I have a Wasm module and I can just import it into another package as though it was another piece of JavaScript. That is absolutely the dream. I think we have seen folks do something like this in Webpack and tools like that, but just to have it natively, I think that's an absolute dream.
Okay, so for me, and then for like the audience as well, how is this like orthogonal to components? Is this just for JavaScript? Like, what's the deeper dive on this one?
That's just for JavaScript. It's like, hey, I'm in JavaScript. I have this Wasm module that exists at this location, and I want to import it, and then it is there for me to use. That is simply it. So instead of having to fetch bytes or read them from a file and then put them into WebAssembly.compile streaming or whatever, instead of that, you just which in fact I actually don't know. Maybe you still have to compile it, but I do know at least you can just import it from a file.
It's all about bypassing that WebAssembly.instantiate call in the global.
Yeah.
So it's about making the WebAssemblies at the same level as JavaScript in the module system.
Yeah, so that's a super big deal. But yeah, you're not getting any of the special types like that you get from the component model or anything like that. You still got your I32s, your F64s.
And if you're using a Wasm GC language, you get those reflected into JavaScript with some more of the other proposals that the type reflection we just talked about. So
it's phase 3, which is implementation. What's keeping it from going up to phase 4?
To be real with you, dog, we really only pay attention to implementations outside the browser. But so this would be like, just 2 browsers have to implement it. I think is kind of the big thing. Our 2 runtimes, I should say. In fact, I imagine, I don't know what the state of this is in any of the runtimes.
The champions are two folks from Igalia who work on web engines, and Guy Bedford, who works. He used to work actually on Wasm Time and Jco, and now he works at Cloudflare on things related to their WebAssembly. So, Cloudflare, of course, it's in V8.
Gotcha.
Indeed.
Always appreciate when Oscar keeps it real with me. Let's move on. What do we have next?
Next up is wide arithmetic. Which I love them thick numbers, but I want you folks to give me your opinions on this. So the reason for wide arithmetic is let's say you are multiplying 2 numbers together and it's going to overflow. Right now, WebAssembly has no notions of getting access to the overflow value or whether you even overflowed at all. In SIMD, there are some operations that can give you this, but there are no non-SIMD versions of this. And so this is a big deal, particularly for folks implementing like big number libraries.
Cryptography in particular.
Or the scientific community, right?
Right, exactly. So this is kind of a big deal.
And
which actually
it comes up in basically every program that uses a pseudo-random number generator as well. That's used inside your hash maps and so on. So it actually comes up quite often.
Which the question I have, and Pat, you might know about this. What is the struggle with different architectures for this one? Because I know some processors.
I don't think there's actually a big struggle with different architectures on this one. I think there's a struggle that it's just a small incremental improvement and it needs people to push it over the line in the various engines.
Got it.
So this one, Alex Creighton and Jamie Sharp came up with this actually when they were profiling stuff in Wasm time. And like, why is there all these instructions here? And it's because, because LLVM can't count on I64 multiplies and being able to find out whether they overflowed or what the high significant divot is. LLVM generates really inefficient WebAssembly, and then crane lift in turn generates really inefficient machine code. So this is about, if we can generate straightforward WebAssembly in LLVM, then it turns into straightforward machine ops in machine code.
This type of arithmetic right now in WebAssembly is about 7 times slower than native hardware, right? So definitely some pressure to fix this.
Yeah,
for sure.
I think this is really
one even closer to native speed for Wasm.
Right. This is really one that just needs people from various engines to go out and implement it, and I hope that happens.
Yeah.
Well, it is an implementation phase, so.
All right, go forth and implement.
Yes, go forth and implement, folks.
All right. So now we're going to bump down to phase 2. So why don't you explain real quickly what phase 2 actually is?
Yeah. So phase 2 is so someone has proposed an idea, and then someone sat down and actually did the work to come up with spec text. So this is all right. People already debated whether or not it was a good idea to even do the thing, and now people have actually sat down and said, okay, what would this look like if we actually spec'd it out? And that's the stage at which it's available for people to then continue arguing, mostly in terms of, okay, based on the spec text, are we actually able to move on to trying to implement this?
Is this the stage? Oscar, is this the stage where you might get a working group or a subgroup meeting, or is that before or after this stage?
Yeah, for this, you're really you're still just going to the community group meetings. You're still talking about it.
Yeah.
So the reason why this is a big deal is because for everything that's in phase 1, which is the stage before this, it's just all talk, right? This is the moment where you actually sat down and did the work to try and start making this a real thing.
This is where you're walking the walk, right?
Yeah. Now you're walking the walk. You're not just you're not just talking.
The community group has voted that what you've produced so far is worthy of consideration.
Yeah.
Cool. So what's first up? Is it relaxed dead code validation? Are we headed there first?
Indeed it is. And so this is another fun one because this one is championed by Conrad Watt and Ross Tate. And so I don't know why this is necessary in WebAssembly. I don't know what compilers are generating code where you have dead code where it's like, it'd be really handy if I didn't have to worry about this validating properly. I don't know the exact reasons for this. But if Conrad says we need it, then I trust him. That is my stance on this proposal.
Okay.
I do too, but I'll point out that Conrad hasn't pushed a commit to that repo in 5 years now. So I don't know why it went dormant, and maybe it is a dead proposal that just hasn't been moved off yet, but there it is.
Oh my. A dead proposal about dead code.
Right.
Okay.
I think that dog is just as mad about this as
sorry, that dog picked a really bad time.
Yeah. So one thing that I think about in terms of my compiler experience, compiling in WebAssembly, there are times where you have a branch that's really going nowhere or doing nothing. And I have found it is a little bit of a pain to get the WebAssembly code to validate in those branches, particularly because this instruction branch is expecting you to return an I-32 or something like that, but you don't have an I-32, and it feels really weird to just generate code to make it validate. I've definitely run into that. I feel that unreachable is kind of your friend, though, where it's just, all right, yeah, just here you go. Here's your unreachable. Leave me alone. So yeah, I don't actually know too much about this one. So maybe I'll ask Conrad to yet again explain it to me and see why it's really necessary.
Okay, and it looks like we have up next numeric values in Watt data segments.
Yeah,
they can only be strings, right?
Are not just strings. You can have, well, I suppose they are strings, and I suppose if you just have raw bytes, I guess you're just doing just escapes if you have raw bytes. The numeric values is handy. There's cases where it's like, I just want to have this data somewhere, and it is just this number, and not having to go escape it to figure out what it's supposed to look like. particularly when it comes to Indianness. Like that is a thing that messes people up a lot in WebAssembly. So yeah, this is handy. Just improves WAT. I don't think it changes encoded WebAssembly at all. So just makes it easy to write Wasm by hand, which useful to me.
Okay. Anybody have any major objections to this one? Hearing none, moving on. Next up is extended name section.
I'm bad at
these are deep. These are definitely deep.
I'm very bad about the name section and actually populating that to know what things are called or should be called. In fact, and maybe Pat, you know better than me on this one. For the name section, is this just for names of symbols, or this is also the producer metadata as well?
No, this is actually just, there's a handful of things that the names section couldn't give names in MVP, like globals. You can give export names to globals, but if you have a non-exported global, there's no way to assign a name in the name section. I think memories you can give a name when you export, but not when you define them. So it's just one of those like, okay, so giving things more local names, there's no harm in it. Names are non-semantic value, right?
Names are cool.
But also, this is one that hasn't seen commits in a couple years now, and I think it's because it's one of those like, well, it's probably pretty nice to have, but I don't think it's making a break
imperative, right?
I see. Yeah. I'm sensing a common theme here with some of these phase twos. That they are great ideas. They're nice to haves, but nice to have is not enough to get people off their butts to implementation.
Indeed.
Now, the next one up is custom page sizes. I think we have some opinions on this one, don't we, Oscar?
We do have opinions on this one. In fact, I don't know if you saw who's championing this proposal.
Nick.
Yes, Nick Fitzgerald. So yeah, custom page sizes. This is a big deal, actually. So for those of you who aren't super aware with pages in WebAssembly, WebAssembly pages are 64K. And so WebAssembly memories are measured in pages. So if you have a WebAssembly module, the smallest amount of memory that can be assigned to that module is 64K. For most people, that sounds pretty small. Like, who cares? That's not a ton of memory. Like, we can always grow it from there and do whatever. But when you start thinking about small devices or having
like IoT in the embedded community, right?
Indeed. Yeah. You have these, or you want to have multiple WASM modules working together and they all have their own memories, those 64Ks can add up. So the reason why 64K was chosen, I believe, is because it was a multiple of the common smallest page sizes among different architectures. I think that's why 64K was chosen. But
yeah, there's one older Android phone ARM architecture that had 64K pages. But at this point, those are all unsupported. So if WebAssembly were designed today, they would probably land on 4K pages.
Right.
I see.
But yes, so the idea here is, hey, well, we want to fit WASM into smaller places. We should have smaller page sizes. Funny thing about this one, there was a whole bunch of debate around how you specify what those page sizes are. And the thing that we ended up landing on was there are two options for page sizes in WebAssembly. You'll have 64K and 1 byte. And you can go from there. So, folks who have just heard this, like, what are your thoughts on these page sizes?
Yeah,
I mean, the 1 byte has always been weird. Sorry, Joel. Yeah, the 1 byte has always been weird, but it's malleable, right?
Yeah.
I
think with component model, it makes it more likely that you're going to get into a need to have custom page sizes. The components are going to be operating on different things, and maybe some of them need to be operating on smaller page sizes, right? On the same system.
Yeah, in particular, it's because when you stitch, like in the component model, if you stitch multiple core WASMs together just to create one module, so we're not even talking about composition of components, just stitching multiple core WASMs together, and they all have their own memories, those 64Ks are going to add up. And then the moment you do that with multiple components, then now you have even more, and it's, very quickly you can get to a place where you've claimed at least a whole bunch of memory for these components. Of course, there's lots of tricks we can do to say, hey, well, you're not actually using that much memory, and so whatever. But it is handy to be able to say, hey, actually, we still want to do that. Having those small page sizes, like maybe this thing only needs 256 bytes of memory. Right. Like, it's not actually doing a ton of stuff, or maybe this thing doesn't need any memory at all. in actually thinking about those use cases.
Where does that all happen? So, like, if I'm writing some JavaScript, I'm going to pass it down to, let's say, like Wasm time. Is it Wasm time that's figuring that out, or do I give it hints that say, "Hey, that's like when I create my memory space or I instantiate a memory space, I say, hey, like this is really 4K. I only need 4K."
Yeah, it's encoded into the Wasm module itself.
Yeah,
that's awesome. I love things that are more memory efficient, definitely, especially working on the things we work on. Next, shifting gears almost completely, is stack switching. I'm imagining you probably have some opinions here.
Oh, this is the most important one in all of phase 2, to be honest. Stack switching is like the major feature that hasn't already hit a phase 4 or 5 proposal, as far as I'm concerned. It's the feature that every real processor has that WebAssembly doesn't have, right? And so when you're porting programs that make use of set jump, long jump, it's like, okay, we were able to implement some of that in terms of exceptions, but some of the more sophisticated things that can do, we really do need, like if you're using coroutines, you really do need this stack switching proposal. So yeah, a lot of things in like the Go programming language, lots of other languages have coroutines as well. They need stack switching to be efficient, and the language should really have it, or the VM should really have it.
Yeah, I was just gonna say, this is another one where it was fiercely debated, where there ended up being two completely different camps on, hey, how should stack switching be implemented? And I think that type of discussion is fantastic. It's amazing that we can have folks be very passionate, have very real concerns about implementing one or the other, and just how it will affect compilers in the future, and how folks use this. So yes, this is one that has taken a long time, just to get to even the stage it is now, let alone actually, implementation phase and actually getting implemented in places. But I think that's okay. I think this is one of the ones that's so fundamental that it's perfectly fine that it has taken this long.
For a feature that's so, for the feature that is, as described by Pat, so important, what's the next step here? I mean, what's keeping it from going up?
This is a really challenging thing to land in engines because it's very fundamental to how the engines work. So the team that worked on this did a prototype in a fork of Wasm time, and we've been step by step bringing in their code, and it's a big job. And I know that in web engines, the V8 team was also really big in collaborating on this one, and I know they had a lot of struggles with their internal architecture and bringing this one in. So I think it's just a really big change.
Yeah, so this is one of the few proposals where, yes, it's just in a stage where there's spec text. It's not, and you're hearing people are implementing it, so why isn't it in implementation phase? And it's simply the matter of, we're not even sure exactly what the spec text should really be, to the point that it's like folks need to actually go implement and try things so we completely understand it, so we can say, okay, this is what the spec text should actually be before pushing it forward.
But it's nice to hear that these are concrete engineering problems, right? Like, it's just, I mean, I shouldn't say just, but it's getting through difficult problems, but it's on the engineering side. It's on the technical side.
I see. It almost sounds like there's a need for another phase, like experimentation.
Experimentation
not,
phase.
Not that I would propose another phase.
Yeah, let's not add more phases. But yeah, I remember in some of the in-person Wasm CG meetings, folks talking about this, debating about this one, where there were some people dissenting about how we should move forward. And then having someone call out, hey, in the notes, please note that it was people from this specific company that said that they did not want to move forward with this proposal. And so I think that's an interesting thing. That's not something that's really ever noted in the notes. And so that's kind of a fun thing, just for people to have context, like, oh, hey, maybe go talk to these people, see what's going on, and why we should or shouldn't move forward.
All right, moving on. I think our next up is rounding variance. Any objections to more precisely rounding floating point?
So the idea that there's the behavior around rounding in WebAssembly is trying to be deterministic, and it picked the way that it would be straightforward to make it deterministic across all the processor architectures that this has to target without giving any of them an advantage or the other. And so the cost of that was excluding some rounding modes that are useful to have for certain kinds of programs, right? And do they work on our architectures? I guess they don't. Or if they do, I don't know what the actual minutia is here. This is one where, frankly, I don't know a lot about the minutia, but I do know that the spec originally left it out because it's a ball of hair. And so this is trying to say, oh, let's attack that ball of hair. And I guess what I haven't really seen is like a huge willingness from the community to go in and bring this along to the next phase yet. It seems like it's basically a one-person proposal right now, which kind of keeps it at phase 2.
Well, if you like reading tables, there's a lot of great tables in the overview section. Let's move on to compilation hints. Oscar, got any opinions on this one?
For me, my opinions are the same as last episode on, branch hinting, where it's, yes, this is useful. It makes your Wasm go vroom in the particular engines that are going to support, actually compiling your hints. But I just have mixed feelings because to me, this gets into places where, oh, well, this Wasm module runs really good over here, but it doesn't run really good over here. And so is it really portable? and that's the part that I don't really like about these types of things. But like, obviously, yeah, it's fantastic in terms of getting the most possible performance out of your WebAssembly and engines that support it. So yeah, just the same mixed feelings for me.
I mean, I think it can open up WebAssembly or make like the high performance compute or high frequency trading or like things like that, or like huge scientific applications, make it more palatable to adopt. I don't know. It feels like an opinion.
Yeah. All right. Rounding this one out is custom descriptors and JS InterOps, and this has implications for Wasm GC, doesn't it?
I don't know.
Yes,
What do you think about this proposal?
This one's about just getting. There were things about Wasm GC and its JS interop that I think, again, because they're tricky, were left out of previous proposals because they weren't essential as part of the MVP. And this is some of those things we had to table and set aside. Here's a separate proposal tracking later that'll ship later that'll fill in those gaps. I don't think there's anything wrong with doing that. It's a great way to divide up work and so that the most important part ships first. And from what I can see in this, it looks pretty good. Let's ship it later.
Yeah, actually, looking this over and paging it back in. I actually remember this now. I remember the debate about this. And I'm actually really glad this got separated out from GC, because like the whole point of this was can you remember what type of object in JavaScript is associated with this GC struct? Like that's kind of like the fundamental thing about this proposal. And I'm very happy this was separated out, because it'd take a while to fully figure this out and get it implemented, when again, it's kind of only important for JavaScript in this case. And other languages might want something like it, and so then we need to talk about it and figure it out, and that sort of thing.
All right. And
it sounds like
go ahead.
Oh yeah, it sounds like there's a theme to these second phase proposals where like there were a lot of pragmatic decisions made to get something to users to verify, and then these thornier problems will be caught up with later, right?
Huh. Interesting. Phase 2, parking lot or dumping ground? Who knows? So let's move on to phase 1, Oscar. Now there's a ton of stuff in phase 1. There's 12 proposals, at least by what I can see here. This is a phase proposal. This is just feature proposal, right? This is just someone's got an idea. Is that correct?
Pretty much. This is like a serious idea, because to be fair, if you just have an idea, it's phase 0. But basically, you've presented this idea to the community group, and the community group said, "Let's talk about it."
Yeah,
that's where you're at with these.
Well, with 12 remaining, I don't think we have time to go through every single one of them, but I know that there are some that people are interested in talking about. And so why don't we go through and just pick one out from phase 1? Oscar, what do you want to pick out?
Component
I know
model.
what I was about to say. I think your eyes are shifting down the list to component model. So what do you have to say about component model, Oscar?
I think it's kind of hilarious that this is a phase 1 feature proposal. Largely because we've been talking about the component model for ages. We've been talking about it's this big thing. It's going to change WebAssembly forever. Like, yes, component model this. We're talking about, hey, we're going to ship component model. There were rumors that component model was going to get shipped this year. And how is that happening? And this is still phase one, which
Great question.
Pat, being as involved in WASI as you are, and WASI Preview 3 and the component model being so tightly knit together, what is your take on why component model is still a phase one proposal?
Take on why this is a phase one proposal is because no one's done the work to bring it through the phases yet formally, but the work on the spec and the work on the implementations is all there and exceeds, in fact, many of the phase three proposals. So, the component model we're iterating on, we did an 0.2 release to coincide with WASI 0.2, and then there's new features coming in 0.3 and non-breaking changes planned for patch releases later in the 0.3 series that'll add all the async stuff. So this proposal is really mature, and you can use it today and trust that the engines that support it today will continue working with the preview versions of it in the future. And that's fine. Because you don't actually have to implement the component model natively on any runtime. And our proof of concept of that is that Jaco implements the component model for web runtimes just using plain old JavaScript. So it's okay to have this be unstable or still in development in a way that, the ones that add opcodes to the instruction set are not. Because you don't need the WebAssembly engine to know about the component model. It exists outside of it, just like JS InterOps exists outside of it.
It is a little shocking to see it stuck down there in phase one, but it just sounds like there needs to be a final push there, right?
Well, so is it worth advancing it, right? Because there are different stages of the component model where we're in the stage where, okay, we got all the types in there. We have the canonical ABI, that's a thing. And we're in the stage of, okay, async and futures are the kind of the big thing that are being implemented right now. Is there more spec work to be done on the component model?
The spec work is really informed by the working on the actual implementations. That, as we're implementing it, we're discovering, the spec about this doesn't work out as well as we hoped, and then lots of revisions go back in. So it's fine to just let that happen in the form it's happening right now, where the spec and implementation feed into each other constantly. And when it's done and it settles down and there's a component model 1.0, then it can move through the phase process here.
And in truth, is the spec ever really done? Honestly.
Well, no, but you can at least split things out into later proposals.
True.
It's like bonsai. It's the journey.
Constant pruning.
Yeah.
Pat, from the phase one proposals, do you have one that you want to talk about?
Well, I said last time, I think one of these shouldn't exist. I think one of these is genuinely not a worthwhile idea. And so the one I'm going to pick on for that is the WebAssembly C and C++ API. So the story I always tell people is WebAssembly used to be simple enough that you could write an implementation in a weekend, and a lot of people did. And so there was 25 WebAssembly engines that were all about a weekend or 3 or 4 worth of effort, right? And as you get exception handling and GC and all these other features, that is not the case anymore. WebAssembly engines are big and complicated, and it takes a lot of engineering effort. So there's no longer a huge proliferation to choose from. And when you're picking one, you've really got your reasons why.
Right.
So the idea of this C and C++ API was that, if an engine exports these C symbols, and you can use this C and C++ headers to use it, then you can swap in any engine you want. But at this point, what's the value in being able to swap in any engine you want when they're pretty big, they're pretty sophisticated, the functionality covered by these APIs is pretty small. It doesn't really let you do the important things that a lot of these engines actually do, especially with newer proposals. So I think this one's dead. I think it was an experiment, and it's okay that some experiments fail.
Yeah, no, I will say that back in the day, this was important. But I think even back in the day, we saw the fragmentation for this, right? Because was it wasm.h or was it webassembly.h? I think it was wasm.h. I think like there was always that, and then for every runtime there was the okay, and then here's how you get the good stuff, like for my runtime. And so yeah, I think I agree with you here, where it would be really nice if we had something like this, but I think it's just kind of a maintenance burden for a lot of runtimes, and just quite a lot to put in there. Now,
Right,
that's
exactly.
said,
How do you keep all those features up to date, right?
right.
Like, and then there probably will be some divergent features at some point.
Yeah. But yeah, on top of that, what I think would be super hot is if there was a wasm.wit, where, if a runtime supported it, and I can call into, this WebAssembly runtime from a component. Oh, now we're talking. Now we're really onto something. And so that would get me really excited.
Yeah.
And so whatever runtime decides to implement that, gets my vote for the next election.
I look forward to your proposal, Oscar.
Yeah, here it comes. Here it comes.
All right, Matt, do you have one you want to pick on or pick out?
I can't get put on the spot. No, I do not.
Okay.
I do not.
All right.
Sir.
I'll go ahead. There's something that is not even in phase one that is a little surprising to me, and I think in phase 0, if we dug down into there, it would be the efforts to handle telemetry. So I think WASI Observe is the project where that's being done, and it's being done offline and out of band. And there's a proposal in phase 0 for adoption of that, and I do not see it in phase 1, and I think that's a miss. What do you think?
WASI Observe is a weird one.
Yeah,
it's because I think the ideas of like, hey, yeah, let's have a way to observe, what's going on with WebAssembly modules. I think that's fair. That's a fair idea. But I think, when it comes to actually implementing it in a proposal, people have different things that they're concerned about, where it's like maybe in this organization, I really care about observing things in this way. And in this organization, I care about observing things in this way. And so I think that's probably why it's still phase 0. I just think there isn't consensus on how people actually want to observe things in WebAssembly, without going into any of the political reasons why there isn't consensus on this.
It seemed like the WASI Observe group was kind of reinvigorating some of the efforts as WASI OTEL, right? Which is saying, okay, observability as a field is too broad, but OTEL has made a narrower subset that a lot of people have agreed is useful. And obviously there's some people who don't want to do that and they want to do something else.
Yeah.
Well, I look forward to seeing how that moves on up through the phases. Unfortunately, with that is all the time we have today. So that's a wrap on it all. Phases on Stunning. Thank you for Pat for joining us in the Thunderdome today. And as always, thanks to Oscar and Matt for their usual co-host duties. Before I go, a quick reminder, working on open standards is like trying to be a DJ with 12 people independently controlling the volume. As Wasm aficionados, we're dedicated to the success of this technology, and the fact you're listening in means you are as well. Thank you for joining us. If you hit that subscribe button, we would really appreciate it. We're happy to have you here. Make sure to subscribe. It's a big application world out there. It's time to unleash the power and promise of WebAssembly. So from all of us, thanks for listening in, and be sure to subscribe for future WebAssembly news and views. Till next time, take care.